So for part A, it's a little bit of a poorly worded question, but it does say that it wants you to write first as a single trig ratio, then evaluate. For part A, you could evaluate this right away. Is pi over 4 on your pi plate? Yes. I know that cos of pi over 4 is root 2 over 2. I know that sine of pi over 4 is root 2 over 2. I could square root 2 over 2, minus squared again, root 2 over 2. Can you see that the answer is 0? Just using your pi plate. Okay, but we're not supposed to do that first. We're supposed to do that second after we write this as a single trig ratio. So we're going to have to go to our formulas and say, do we ever have a formula that's cos squared minus sine squared? And the answer is yes, that is one of our double angle formulas. It's equal to, and I'll write it up here, on our formula sheet we have that cos of 2 alpha is cos squared alpha minus sine squared alpha. And then notice here, those angles are the same, so it matches up with the right-hand side of the formula. It allows you to change to the left-hand side of the formula, which would give you cos of 2 times pi over 4. If I multiply 2 times pi over 4, I get pi over 2. On our pi plate, cos is the x-coordinate. At pi over 2 at the top, your x-coordinate would be 0, which we figured out the other way, excuse me, already. But it shows that we could do it this way as well. Same thing in part B. In part B, you could evaluate this already because you know that tan of pi over 6 is root 3 over 3. So you could plug that in and evaluate. This question wants you to change it as a single trig ratio. But when I look at my formula, oh my goodness, I'm going to write out the formula for tan 2 alpha. It looks so close. It says 2 tan alpha over 1 minus tan squared alpha. Does it match perfectly? No. Our formula has tan squared alpha minus 1. It's very close, but slightly different. In these situations, in order to change it, it has to match perfectly. So what I'm going to do to make it match perfectly, I'm going to rewrite the top because the top matched out perfectly, right? But if I factor out a negative 1 out of the bottom, then my 1 would become positive and my tan squared would become negative. And again, something about negatives and fractions. And I'll just, don't have to copy this down. But if you have a negative in a fraction, and right now I have a negative on the bottom of my fraction, do you agree that 2 over negative 3 is the same as negative 2 over 3 is the same as negative 2/3? We have a choice where we want to write that negative. That's going to be important because right now I'm going to decide to erase it. Wow, with a huge eraser. There we go. I'm going to erase it off of the bottom and instead put it out in front. And I'm going to even put this in a big set of brackets. Because now what's inside the brackets matches perfect. And the only way I can use a formula in identities is if the formula matches perfectly. So now that it matches perfectly, I can substitute this to be tan 2 times, and the angle alpha is pi over 6, which will give me negative tan. If I multiply that through, it's just tan of pi over 3. On our pi plate, tan of pi over 3 is root 3. We still have that negative out in front, so we get negative root 3. I'm going to add 2 questions to this one. Because what I don't like about A and B is both A and B use values already on your pie plate. So I would say if you were asked to evaluate, probably you would plug things in right away. But what if you've got things that are non-calculator and not on your pie plate? For example, here, I'll just add the word. This time we're just going to evaluate, which evaluate means come up with an answer. Non-calculator, and I throw out a pi over 8. So it appears scary to begin with, because never done pi over 8 without a calculator. It's not on our pie plate. Seems impossible. But if you had 1 minus 2 sine squared pi over 8, you go to your formula sheet and you're like, oh, look at this. I have this formula. One of my formulas has a 1 minus 2 sine squared alpha on the right. That means I can take all of this and change it to the left side. And if I change it to the left side, I would have cos 2, and then my alpha is pi over 8. And if I multiply 2 times pi over 8, how do you multiply fractions? Multiply the tops, multiply the bottoms. I'd have 2 pi over 8, which reduces to pi over 4. And this would just be root 2 over 2. And I'm going to add one more question. And I'm going to tell you, if this was on the exam, how many marks it most likely would be on. Okay? The final one that we're going to do is going to be evaluate 2 sine of pi over 12 and cos of pi over 12. And this question on the exam is worth 2 marks. Do you remember on Friday we did all of those pi over 12 questions? A single pi over 12 question on an exam is usually worth 3 or 4 marks. If you look at this question and see the pi over 12 and say, ooh, I know how to do pi over 12 questions. This would be a 4-mark question, and this would be a 4-mark question on its own, and simplifying it would be another mark. If that's what was expected, this would be a 9-mark or 7-mark question. That's a lot of work. And yet on the exam it says 2 marks. Because there must be a quicker way to do it. And this is where, if you don't have your formulas memorized, you'll look at this question and your brain will see pi over 12 and go, I know how to do pi over 12 questions, let's go. And you do it like a 7-mark question. Yeah.
Sorry for the interruption with Gabby
You get the
Torres,
same formula sheet
Angela
on the exam.
Braga, and Olivia Sandflake. Please go
But
to
if you
theater right
recognize
away.
this formula,
Gabby,
or if you have
Angela,
this
and
formula
Olivia, the grade
memorized,
Student council, please go to theater right away.
that sine 2 alpha is 2 sine alpha cos alpha, then we could take this question and say I can substitute the right side for the left side, and this becomes sine 2 times pi over 12, which is just sine of pi over 6. It's on your pie plate, and the answer is a half. I will tell you that if you did this the other way, you would get root 6 plus root 2 over 4 for this one. Root 6 minus root 2 over 4 for this one. If you multiplied them out, it would all reduce and simplify to be a half after a page of writing. This is way simple. And then once you get into higher math, what do they like to do? They like to have these formulas, but like do one mental math manipulation, like take away the 2. Or change the number in front to an 8. Right? Anyways, questions for this one are 4, 5, and 6. Have a wonderful night.